Good morning, everyone. Thank you, the conference board, for this opportunity. Thank you, Yak, for representing our big data research lines, and thank you, Eric, for the previous talk. So my name is Feras Mahmoud Awaysheh, and I will represent today our data system research group and the ongoing research line behind our big data research lines. And as it's indicated in the title, the next big thing in big data, the edge intelligence, where data analytics meet the edge computing. And my argue for today would be edge intelligence is the silver bullet for every and each of your problems. I'd like to say that it's true, yet it's not. What I will be representing today is that our computation at the edge of the network, our mobile phones, our laptops, our tablets, and other devices at the edge had developed to become like a very powerful resources to be wasted. And against the previous paradigm where we put all of our big data in a centralized repositories to make some analytics and grab some knowledge. Nowadays, we are moving toward more decentralized architecture, and this is where the data science and big data research meets the edge computing. So first, let's talk about, and I'm sorry if I over-designed my slides. Let's talk about two fundamental questions. How big is our data and where does it come from? The left slide or figure here shows that as a civilization, as a humanity, we are allocating and grabbing more data than ever, like in daily basis, like in one day, we allocate more data than a year back in the 90s. And the numbers keep growing very explosively. And where does all of our data come from? Many and multi resources, and IoT devices are among of such paradigm that shift to more big data allocation. So we have sensors, actors at the edge of the network, keep tracking our daily behaviors and allocating more and more data. And if you look to the left figure, we can see that tweets, YouTube uploads of videos, and much more from experiment of science, smart vehicles, many more resources are keeping the number increasing. So the development of IoT is expected to have a boost in the next 5 to 10 years, generating more data. And as a big data analytics, the more data we have, the more happier we are, because we can run more sophisticated analytics. We can grab more knowledge from our architectures. So we are living in a data era where, as much as I said, as much as data we can allocate, the more knowledge we have to submit for the decision makers to make more sophisticated, more advanced, and more wisdom in their decision making. And we can run more like modern applications like smart homes, intelligent transportation system, and autonomous vehicles, and industrial IoT industry in general. So the art of data is that we allocate as much data we can. We run data processing, transfer this raw data into information that we can understand. And by running more data analytics, we can have knowledge out of this information. And the ideal is to have insight. Insights means intelligence. Intelligence means smart, more sophisticated decisions. And the ultimate would be having the ultimate wisdom, making all the previous process more optimized and more useful. From an architectural perspective, and as I said, usually, let's take it from this neural network image, where we allocate the edge nodes far at the network's edge, and we have some other computation and storage capacities in the fog edge paradigm. And at the heart of all of this, we have the traditional cloud computing centralized infrastructure. So our argument today is that instead of maintaining all of our data in centralized cloud, some application required tolerance and quick response, that the process needs to be take place at the place where we allocate this data. So the goal is to unleash the services, the analytics, the data processing to the network edge, and the ultimate goal would be connecting everything and at every time. This can be motivated by highly dependence and fast and smart analytics of our systems, and making people less integrated into this cycle. As the end of the day, we're talking about an intelligence era, artificial intelligence era, where the system themselves can make the decisions, as it's expected that 40% of IoT applications will rely on local data analytics, either at the far edge or at the fog computing. And a key concept here is data privacy. As much as the data analytics would like to allocate every data that we can put our hands on, yet data privacy is a concern, and as a human beings, we appreciate our privacy more than ever. So how can we maintain sophisticated architectures while allocating as much data as we can, yet meeting the privacy? And this is where the edge intelligence came into being. So edge intelligence in a concept is about shifting the AI into the edge of the network, as mobile phones, smartphones, laptops, and the term edge is maybe a gray area where we sometimes consider like a whole institute as an edge node, and then sometimes we consider a mobile phone as an edge node. So how can we define that? The edge means decentralized, that's for sure. So imagine a bank architecture where we have the headquarters and different branches. So if we run the data analytics at each branch to trying to maintain the data locality, not moving the data through the public networks to the headquarters, this would be ideal. If we can run some machine learning for natural language processing over your smartphone without sharing your privacy data to the cloud, this will be ideal. So intelligence means making decisions, and those decisions has to be right at the right place and right time. So traditionally, and from, as I shared in the architecture before, so we have IoT devices at the edge, and we have intermediate layers and cloud or centralized architectures. In the old school, or traditionally, we grab the data, but we process it and making informations in more centralized architecture, and the knowledge can be only in the cloud or the data center. Yet today, all level of knowledge, from data to wisdom, can take place at the far edge, intermediate, or centralized. The motivation behind that is that we can do so. We have more capacities than ever. We produce data at the edge more than ever. And the more proximate to the source, the more response time you have. So it is low latency to make speed in the decision. and reduce the global bandwidth and communication. And local means security and ownership, privacy. You don't share your data, yet you can take advantage of some sophisticated systems. And the idea is that we need to build the knowledge and make analytics and predict some patterns. And we can take the decision locally, and we can share this knowledge among our peers. Imagine an autonomous vehicle, an intelligent transportation system where the car can allocate from the sensor more data, analyze it, find patterns, and share this knowledge to other peers, like there's a hazard area, there's an accident, there's something in front of you. So it gives sense. Then keep doing it again, machine learning, running another round of knowledge till you have better decisions, and so on and so forth. This can't be done alone. Like, doing this very challenging and very promising paradigm requires synergizing efforts from different vectors and different angles. So from network, the SDN and NFV's network, virtualizing your infrastructure and using some modern networking paradigms can help in achieving our goals as data scientists and big data architectures. The talk about the beyond 5G and 6G architectures and communication systems that will boost the number of communication between vehicles, mobiles, etc., and in and out of the cloud. And of course, the containerization technology, which is a lightweight virtualization technology that enable you to wrap all of your workload in a safe and isolated environment, like a sandbox where you can run all of your application in a safe zone. Yet there are many more associated technologies. Those are to name some. The application of such work, as you can see, is a very broad spectrum. It can range from the healthcare systems where your patient can be in home with some sensors, and you can take some decision, for instance, call for an ambulance or call for help. Running also in the healthcare, like synergizing different institutes in pharmacy and drug discovery. Like when we faced the COVID pandemic, a key to our success in facing another such pandemic is synergizing efforts from different institutes and service providers, yet they don't like to share their knowledge, their results. So what we can do is that they can run a local data analytics and find a way to fusion this knowledge. And among of these applications is the federated learning. So federated learning is a machine learning, a distributed machine learning, where multi-actors can build a common robust and distributed machine learning model. So the cloud can agree on one machine learning model that will send this model to the edge nodes, run this model based on your local data. Don't share your data. The allocated data at your edge of node. It could be mobile, smart vehicle, whatever is the edge node is. So we send a common model, run this model on your local machine, and don't share the data. Only share the weight of this model. So if there was any man-in-the-middle attack, the weight of the model means nothing for you unless you have the original model that you can run and see what it means. So we maintain the data locally. We share all the weights, making an averaging or fusing or whatever algorithm you're running, and update the edge nodes with this updated weight to run another round of machine learning with more accuracy at your edge node. So Data processing and analytics close to the source is very critical to develop our big data architectures, especially when we're talking about privacy and time latency are very critical. AI is a key in maintaining this vision, and decentralizing this process is the next big thing in big data. Actually, it's maybe the final mile to achieving the wisdom out of all of those distributed edge nodes. So thank you for your attention. I'll be happy to hear your questions. I have some references about our recent publication in this regard and this term, and the floor for you. Thank you. Thank you.
Thanks for the presentation.